Welcome to another informative series on matter measurement. Today we will be looking at level sensor and its applications in industries. So what exactly is level sensor? Level sensor is an electronic instrument that measures fluids level. This instrument converts the varying fluid levels to electric signals. These electrical signals are in the range of 0 to 5 volts or 0 to 10 volts, and 4 to 20 milliamperes. This generated electrical signals are sent to a programmable controller, also known as PLC. Levels sensor comes in two categories, which are point and continuous level measurements. Point level sensor are usually placed at a specific height. The sensor will be activated when the content within a vessel levels up at the sensor height. This increase in level activate the point sensor. Once is activated, the sensor will send the corresponding feedback to the PLC. Continuous level sensors on the other hand are more sophisticated, because it provide a continuous level monitoring of a storage vessel or container. They measure fluid level within a range rather than at a certain point. This means the level transmitter measuring range is not at a certain point. This instrument produces an analog output that directly correlates to the level within the vessel or container. The analog transmitter generated will be sent to the PLC. The varying output signal is usually linked to a closed process control loop. This applications will be discussed later. Now let's look at the type of level instruments that we have. We will be starting with point measuring sensors. Example of point measuring instruments are optical, capacitance, conductivity and floating switch. Continuous level sensor on the other hand are ultrasonic level sensor, radar level sensor, and differential pressure transmitter. Delta P. Optical level sensors consist of two main parts, which are infrared LED coupled with a light transistor, and a transparent prism tip in the front. The LED projects an infrared light outward. But as the sensor tip is surrounded by liquid, the light will react by bouncing back within the tip before returning to the transistor. The main advantages of optical liquid level sensors are their compact size, their lack of moving parts, and their low cost. Let's look at its disadvantages. Optical level sensors are unsuited for applications where top mounting is necessary. When top mounted, the accuracy of the optical sensors may be adversely affected by moisture condensation. It can also be affected by particle when clog at the tip. Capacitance level instrument operate on the principle of electrical variation, or capacitance of a capacitor formed by the sensor, vessel walls and the dielectric material. The capacitors is made up of two conductive plates which is separated from by a dielectric materials. Let's look at this formula. Capacitor denoted as C is directly dependent on the plate area denoted A, and the dielectric constant of the material between the plates. This capacitor are used to sense liquid that are non-conductive and at the same time have a high dielectric constant. The capacitance of the probe is measured between the inner rod and the outer shell with the aid of a capacitance bridge. In the portion out of the liquid, air serves as the dielectric between the rod and the outer shell. The dielectric, which is that of the liquid, cause a large capacitor charge as it senses fluids. Advantage: this instrument is capable of measuring liquid and bulk of solids. They have no moving parts. Suitable for highly corrosive media. What are the disadvantages? The disadvantages is, there are limitations especially for product with changing electrical properties. For conductivity level sensor, let's look at this sketch. The first sensor, which is sensor A. It is a single-level conductivity sensor. This sensor works with a metal tank that is grounded. The tank is usually used to complete the circuit of the sensor. When the water level reaches the probe, the ions within the solution will activate the sensor. The solution complete the circuit between the probe and the tank. This ions is usually negative electrically. In sensor B, reverse is the case. The tank is not needed to complete the circuit. The ions in the solution bridge the two probes together once both probes touch the liquid. One of the probe will be negative charge, and the ions in the solution will help transfer the ion to the second probe. Unlike the first setup where the tank grounding couple with liquid rise activate the single sensor probe, the second setup uses combination of the probe and liquid rise but not the tank grounding. Finally, the third setup. That is sensor C. It is a multi-level sensor which can be grounded by the tank by having two probes at the same length. The tank will not need to be grounded. Each probe will complete the circuit in reference to the longest probe. This allowing multiple liquid levels to be detected on a single sensor. There are a number of advantages that these sensors have compared to traditional liquid level sensors. Stability in highly corrosive environments. There are no moving parts and relies on a complete circuit for actuation. Less expensive. Can incorporate multiple probes for multiple levels of control. Minimal maintenance, which is due to simplistic design which also prevents fouling of the probes. Float switch. Similar to the float switch we have in a toilet mini tank. That is turning off the incoming water when the tank is full. This design is similar to what we have in an industrial setup. Instead of the traditional turn on and off with respect to the container level, a float switch detects the level of a liquid in a tank or container. It floats on top of the liquid surface and acts as a mechanical switch when the liquid level goes up or down. The float is used to operate a switch, which is, when the water is low, the contact will be open. However, when it is high, the open switch becomes close, thus completing the previously open circuit. Let's look at type of continuous level sensor, starting with ultrasonic level sensor. As the name indicates, ultrasonic level sensors measure distance by using ultrasonic waves. The sensor head emits an ultrasonic wave. The emitted wave will be reflected off the liquid and back to the sensor. Ultrasonic level sensors measure the distance to the target by measuring the time between the emission and reception. This distance can be calculated with the following formula, where L is the distance, T is the time between the emission and reception, and C is the sonic speed. The value is multiplied by half because T is the time for go and return distance. Radar level transmitter. Radar level transmitters work based on the time of flight, which is TOF measuring principle, or time domain reflectometry, TDR. The distance is measured from a reference point to the surface of a liquid. It sends a high-frequency signal from an antenna or along a probe to the matter surface, which is the liquid. The product surface reflects the pulse, and the transmitter receives the reflection. The transmitter will now calculates how long it took the pulse to return and translates that time delay into a level measurement. One thing worth noting. Before applying the radar meter, the dielectric constant of a product must be known because this has a direct impact on the quality of the reflections. Products with high dielectric constant values will reflect strong and clear pulses. On the other hand, a product with a low dielectric constant value will absorb more of the pulse and reflecting less and reducing accurate readings. Finally, delta P. This instrument has been discussed in one of our series. Please kindly check for our twin series on differential pressure transmitter. Now let's end up looking at its application in industries. In an ideal process setup that requires constant availability water within a certain range, level sensor is the go-to device. This instrument is usually used to open and close product inlet valve in respect to the varying liquid. It acts as an interlock. That is when the sensor senses that the level within tank and container is at maximum. When at max, it prevents the valve from opening and such, there will not be water flow. However, when the liquid drop below certain set point, the valves will open, thereby allowing fluid flow to the vessel. Overall, this instrument is a critical part of closed control loop system. Let's do a quick recap. We started off looking at point and continuous level measurements. We look at the type of point and continuous level measurements. We also look at the advantages and disadvantages point and continuous levels measurements. We ended off with its application in industries. That is it for today's lesson. Hope you have learned something today. See you in our next series.